Hello, welcome to The Birth of Modern Astronomy. In this lecture, we're going to be differentiating between the heliocentric model and the geocentric models of the solar system and explain how these models were developed and how they explained retrograde motion of planets. So, whenever you think of the science of astronomy, where did the science originate? Well, most people actually go straight to the Greeks and say that astronomy originated with the Greeks. But in all actuality, our mathematical and scientific heritage of astronomy actually originated with the civilizations of the Middle East. Through powerful observation and very, very precise observations, they mapped the heavens. They used mathematical calculations and geometry to plot positions, and they kept very detailed records of the positions of stars, the positions of planets, and all other celestial objects that were found in the heavens. But the question still remains is, why do the Greeks actually get responsibility for astronomy? Well, they were the first civilization to actually construct models of the universe. So what they did is they took these observations that they also contributed to and made, and they actually created models that say, here's how the heavens actually work, and here's how objects move. Okay? So, but whenever they started looking at the universe, where they thought was the vastness of space, the only thing that they really saw was actually our solar system. So they actually just created models of our solar system. So with that, whenever you start talking about Greek philosophers and scientists, and I differentiate them because, of course, philosophers were early astronomers. They did no experimentation to actually prove their theories. In other words, they just did thought processes, as compared to scientists who actually started to conduct scientific experiments to prove their hypotheses. You first have to go with Plato and Aristotle. These two early philosophers were one of the first to actually create what is called the geocentric model. The geocentric model of the heavens basically put the Earth at the center of our solar system, and it was a stationary body, and then every other planet and every other object orbited around our stationary Earth in a perfect circle. Okay? So what you have is the heavens must be perfect. And the reason, of course, with that being is because of the religious influence on how they developed their actual theories. So, whenever you start looking at this, one of the primary challenges that they actually had was understanding the movement of these objects called planetae, or wanderers across the sky. As you can see right here, you see these two planetae, happening to be Jupiter and Saturn. You notice that they're moving across the sky in a very unique fashion. Well, one of the problems that Aristotle had is Aristotle did not know how to explain this actual motion. It wasn't until much later that we actually started to put together a theory that says, how do we explain this motion called retrograde? As you can see here with Mars, Mars has an apparent path across the night sky. If you look on a daily basis, the planets are going to move across the sky from west to east. Now, of course, we know now because of the Earth's rotation that is why that occurs. But if you observe the position and the motion of the planets over the course of a month or a few months, what you're going to actually notice is you're going to notice that this planet is going to constantly change position. And it's going to be moving and moving and moving across the sky. And then all of a sudden, it's going to give that westward shift. So it's going to be moving east, and then it's going to move west, and then it's going to go back to moving east. Well, that apparent westward shift is called retrograde motion. So this is the thing that they had problems explaining. How does retrograde motion fit into our perfect circle motions and models of the solar system that we currently have? Well, it wasn't until about AD 140 that a Greek astronomer named Claudius Ptolemy actually incorporated a motion that explained retrograde. Ptolemaic model was the most widely accepted model. It was accepted for centuries by the Catholic Church, because what he did is he was able to actually thoroughly explain not only the motions of the planetae, but he was also able to explain the motions of stars. He was also able to explain all kinds of things in this model. But the primary thing that we want to focus on is we want to focus on his geocentric model. He added one thing to the geocentric model that helped push it over the top, and that was a motion called an epicycle. As you see right here in red, you see that he added an additional motion to the orbit of a planet around the Earth. Now you have to remember this is a geocentric model, so the Earth is a stationary body, and then the planets orbit around Earth. And also the sun. That is a primary thing you have to remember. The sun also orbits around the Earth. Okay? So with this, what he did is he added that red circle and said, these planets don't only just orbit around Earth, but they're also orbiting in another perfect circle. And he used this to actually explain retrograde, as you can see right here. Because of that apparent westward shift that he accounted for right here, because of the epicycle, his model became the most comprehensive model of our solar system. And then, of course, it was most widely accepted because of this motion. Now, we do have two types. We have the epicycle, and this orbit around the Earth was actually referred to as the deference. Okay? So, this is what accounted for retrograde motion in the Ptolemaic model. It was the addition of an epicycle. Now, one thing that you have to do is you have to understand, okay, we're going to kind of switch it up here because you've got to start looking at some terminology. So this doesn't really apply to heliocentrism or geocentrism. It's just geocentrism. It's just something that you need to know because you're going to hear them often referred to as inferior planets and superior planets whenever we get to the heliocentric model. Whenever you start talking about inferior planets, it's very simple, okay? Inferior planets are those that orbit within the Earth's orbit, so they're closer to the sun. And then superior planets are actually those that are outside the Earth's orbit around the sun. So it's all based upon position, so don't worry about this because what we're going to do now is go ahead and get into the next model, okay? For 14 centuries, that Ptolemaic model with epicycles was great until Nicholas Copernicus rediscovered another ancient philosopher, Aristarchus's heliocentric model or sun-centered model, okay? Aristarchus also could not explain many of the motions of the sky, and that's why his model was not accepted. But what Nicholas Copernicus did is he had other ideas, okay? What he was saying is, he said, no, the Earth is not a stationary body. The Earth is actually orbiting around the sun, our star, the sun, as well as all the other planets. And what happens is that because our planet is moving faster than all the superior planets, or planets on the outside, that we actually pass that planet, and that makes it appear to shift westward. So what he did is he put together a model that says, look, I noticed that you have planets that demonstrate this retrograde because of they orbit at different speeds. Okay? It's kind of like the analogy would be you passing a car on the interstate. Whenever you pass the car on the interstate, you look over and it looks like the car is moving backwards, but you're actually both moving in the same position. That is retrograde. Okay? So what he did is he actually said, I don't need those epicycles or other complications. What Copernicus did is Copernicus said, I am going to make the model as simple as possible. But the one problem that he had is he still left the perfect circles, and his model did not completely match up with the observations. Okay? So that's what you're looking at right there. There's two models, geocentrism and heliocentrism, and they both have different ways of explaining retrograde motion. So with this, here's some of the foundations of the Copernican revolution. What this basically says is that, look, what I'm doing is giving everyone a new view of the heavens. And I believe that my view is correct. Okay? So what he basically said is he set some foundations. The celestial sphere does not have a common center. So Earth is not the center of everything. The center of Earth is not a center of the universe, but is a center of gravity in the lunar orbit. So in other words, the reason the moon orbits us is because we're the center of gravity for it. All planets, every celestial planet that was observed actually revolves around the sun. Stars are much farther away than the sun. That was one of his primary things. That's why you don't see them move as much. Okay? The motions the motions of stars and planets are a result of motions of Earth, not the celestial sphere. So he had Earth spinning and causing the night sky to change. And that's why we saw constellations move across the sky. Okay? He also said the reason that the sun moves across the sky is because of that rotation of the Earth. And then his final thing was retrograde is not a result of the motion of the planet, but rather the motion of the Earth in regards to that said planet. Just like I mentioned before, we're moving faster than Mars, so Mars will eventually show that backward motion. We pass it on the interstate. Okay? Now, whenever you start looking at this, now you start to say, now I see why these planets actually move backwards. They move backwards because the Earth is moving faster. But notice how they move differently backwards. Notice that Jupiter actually has a greater motion than Saturn. And what that indicates is that Jupiter is actually closer to us than Saturn. And so we were able to start then putting the planets into order based on the observed retrograde motion. So with this, what he did is he, of course, wrote on the revolutions of the celestial sphere. It was published right before his death. And this is considered the starting point of modern astronomy. So this is why Copernicus is considered the father of modern astronomy, is because of this book that actually explained the true motions of the heavens. So here were some objections to Copernicus's view that were actually set forth by Aristotle way before Copernicus even came around. Earth could not be moving because if so, birds would be left behind. The idea of non-circular orbits contradict the heavens, must be perfect and unchanging. And then finally, the thing called stellar parallax. What Aristotle actually said, that is, if the planet is actually rotating, if Earth is rotating and it's moving around the sun, then everything should actually move almost equally, okay? It's kind of like sticking your thumb up in front of your face and like going like this and closing your right eye and then closing your left eye, switching. And you'll notice that your thumb moves, so you put your thumb up and shift your eyes. You just basically close one and open the other, close the other, and you'll notice that it moves. That is stellar parallax. And he said if that were the case, you should be able to actually see stellar parallax. Because you couldn't, Copernicus's view was not accepted, and it was continued on with the acceptance of Claudius Ptolemy's model. And any person who was actually to go against the Ptolemaic model, as you see here, Giordano Bruno was burned at the stake for heresy by the Inquisition. This was standard practice whenever you went against the Ptolemaic model, because of course the Ptolemaic model had backing by the Catholic Church. So, and of course, you were considered a witch for doing this. Okay, that concludes this lecture. In the next lecture, we'll be looking at Galileo Galilei and his observations of the heavens.